Coming to the another dependent sources that is called G and E dependent sources. These G and E are called as a voltage dependent sources. Voltage dependent sources. G is called as a voltage dependent current source, and E is called as voltage dependent voltage source. E source is called voltage dependent voltage source. G source is called voltage dependent current source. Okay. So yeah, this is the main circuit, DC resistive circuit with the dependent sources. The represent circuit having independent voltage and current sources, Vs and Is. These two are called independent voltage source and current source. This is independent voltage source. This is independent current source. Okay. And the voltage controlled current source is 0.5 VR2. This current voltage dependent current source is 0.5 VR2. It depends upon voltage across the resistor R2. Okay. And then next, while another voltage source that is called voltage controlled voltage source is called 0.5 Vs. 0.5 Vs. So 0.5 Vs means this depends upon Vs voltage. So this is called 0.5 Vs. It depends upon here Vs. Vs changes, this also changes. Okay. And then next, here main aim is to calculate the Thevenin's equivalent voltage and the resistance across the RL along with the all node voltages. What is the here we have to calculate? What we have to calculate here means Thevenin's equivalent voltage and resistance across RL, Thevenin's equivalent voltage and resistance across the RL along with the node voltages and current through the all independent sources. This node voltages along with the current in all independent sources, independent voltage sources. Okay. So to find this all voltages, and we have to redraw the circuit like this, voltages and currents in this way. Redraw the circuits and indicate numbers. This is called 0, 0 reference point 0, and this is called load resistor RL, and this is called dummy voltage source introduced in series with the RL, that is called Vx. Vx is equal to 0 volts. And next, if you want to find the current flow into the load, we have to introduce one dummy voltage source Vx like this. Okay. And next, these are the this one node and this is another node and second another node like this. Indicate the numbers here 0, 1, 2, 3, 4, 5 like this, then 6 here. So in this way, we have to represent the numbers, and then by using the numbers, we have to write the program. Okay. Then how to write the program? First one, Vs connected between 3 and 0 DC 1 volts like this. Vs 3 and 0, it is in between 3 and 0, and DC voltage source and is 1 volts like this. We have to write. Then Vs is over. Then it's coming to the Is source. Is is connected between 0 and 1 or 1 and 0. Is is in between 1 0 DC 1 amps. Is in between 1 0 DC 1 amps. Actually minus 1 amps. If it is connected between 1 and 0, DC minus 1 amps. If it is 0 1, okay, 0 1 DC 1 amps. Okay, there is a small printing mistake here. So if it is is connected between 1 and 0, DC minus 1, we have to write like this. Okay. If it is is 0 1, if is 0 1, DC 1 amps, we have to write this. Then coming to the another R1, R1 is connected between 1 and 2, 100 ohms. R1 is 1 and 2, 100 ohms. Then next R2, R2 2 and 0, 500 ohms. R2 2 and 0, 500 ohms. The next R3 2 and 3, 1K. R3 2 and 3, 1K. The next R4, R4 3 and 4, 10K. 3 and 4, 10K. And our RL is connected between 6 and 0, 100 ohms. RL 60, 100 ohms. Then Vx Vx connected here 3 and 6 DC 0 volts. Okay. Then next coming to the G1. How to write the program here for G1 source? G1 is called voltage dependent current source. So G1 is connected between 2 and 3. G1 is connected between 2 and 3. That is called current in this direction. That's why we have to write G1 is connected between 3 and 2 and 3 and 2. G1 is connected between 3 and 2 and it depends upon 2 0. So VR2 na voltage across the VR2 is called here 2 and 0. It is depends upon VR2 and the resistance and gain is called 0.5. In this way we have to write the program. G1 is connected between 3 and 2 and it depends upon 2 and 0 and gain is called 0.5. Like this we have to write the program for voltage dependent current source. Voltage dependent current source G1 is connected between 3 and 2 and it depends upon 2 and 0 branch voltage across the 2 and 0, 2 and 0 and the gain is called 0.5. Then as coming to the another source is called E1 voltage dependent voltage source is connected between 4 and 5. E1 is connected between 4 and 5 and it depends upon 3 0. Depends upon 3 0, 4 and 5 and it depends upon 3 0 like this. Here 3 and 0 depends upon 3 0 and gain is called 0.5. In this way we have to write the program. Then rest so here we have to find the Thevenin's equivalent voltage across the resistance RL. Here oh, Thevenin's equivalent voltage across the voltage and resistance across the RL. That's why so 6 and 0 resistor is present. That's why you have to write the dot TF dot transfer function of V of 6 comma 0 and Vs. Input is called Vs. Here I'm considering as a input is nothing but Vs. Okay. So this is called load. Okay. Then next, by using PSPICE, what are the results we have to get? And then by writing the program, we can observe in PSPICE program. Open PSPICE program. PSPICE AD student. Open PSPICE AD student. And like this. PSPICE AD students go to file and new text file. Okay. Text file. Right here onwards program. First simulation of DC circuit with the dependent sources with the dependent sources like this, right? Text, okay, about this experiment program. And the next first one, what is the program here? VS 30 DC 1 volts. VS 30 DC 1 volts. Right here. VS 30 DC 1 volts. Like this. Next, IS 01. Actually, the 01. IS 01 DC 1 amps. IS 01 DC 1 amps. This IS is connected between 0 and 1 and DC 1 amps. IS DC 0 DC IS 01 DC 1 amp like this. Okay. The next R1 is connected between 1 and 2 100 ohms. R1 connected between 1 and 2 100 ohms. So next R2. Then R2 20 500. Like this, write the program as it is. Okay, from like this. In this way, we have to write the program. Then, after writing the program, go to file, save as, write the name. After that, save as type file is called circuit file CIR in the form of D.CIR you have to save. Okay, dot car. So save. After this icon, press this icon, open. Open, and right here, whatever the file you are saved with the name, that's G here. I wrote like this: GE dependent sources CIR, open, and then it will display the name like this in this here in this icon. It will be display like this. Then next, they press this called run icon, run, and then results will be displayed like this in second icon. First one is called, this first one is called program, and second one is called circuit simulation output. Okay. So this in this first, if it is not having any errors, it will be displayed like this program in this output circuit file, and the next. So these are the our results. So node voltage one is called 97.9860, and node 2 is called 2.0141, node 3 1, and node 4 1, like this. Node 5 0.5, node 6 1, like this we will get the results. And the next, current flow into the uh, name of the voltage source, that's called Vx. Vs is called, what is the circuit? Vs is called Vx. Vx is called, where is Vx? Current flow into the load. You will get like this. What is the, so Vx, current flow into the load is called 1 into 10 to the power minus 2. That is nothing but 0.01. The current flow into the Vx load resistor. And then Vs is called, current flow into the Vs is called 9.94 into 10 to the power of minus 1. That is called 0.99 amps current. Okay. And the next, Thevenin's input resistance from the source side is called 1 into 10 to the power of 2. So 10 square, 100 ohms. Then output resistance at 6, 0 is called 0 ohms, because of voltage source is connected parallel to the load resistor. So under voltage, to find the open circuit resistance across this voltage source is short circuited. That's why we will get 0 resistance. So if I am changing, for example, here, this is called load resistor. Na? If I am changing the load resistor as a 4 ohm resistor, as a, if I consider R4 is as a load, then 3 and 4. Na? So in this program, we have to write like this. In this program, V of 3, comma 4, then we will get another value of Thevenin's open circuit resistance, and then save and simulate, and then go for this way output results, circuit file results. Then we will get different values of resistance. So input resistance is called 1 into E 10 to the power of 200, and then output resistance is called 1 into 10 to the power of 4. Okay, that is called 10K, 10 kilo ohms. We will get a Thevenin's resistance. In this way, we have to find the Thevenin's equivalent resistance. Okay, by using this command dot TF V of 3, 4. If the load resistor, for example, R2, if the load resistor, for example, R3 is connected between 2 and 3. So if I am changing the program in this here, 2 and 3, na, load resistor, for example, the load resistor is connected between 2 and 3, then what is the Thevenin's equivalent resistance? Okay, go to program, open 2 and 3, press for first one, and change here 2, 3. If the load resistor is present across 2 and 3, then change like this, dot TF we have 2, 3, and then save, and then run, and then we will get the results here. So from here, what is the output resistance? Here output resistance is called, so output resistance is called 2.012 ohms. E power 0 means 10 power 0. Input resistance as it is 100 ohms. So if input resistance, I'm considered as an input to the current source. For example, instead of Vs, Is is also source present. If Is I consider as an input, so then save and simulate, we will get another value of input resistance. So input resistance will change. From source side, what is the equivalent resistance? So previous 100, now input resistance is called 9.79 into 10 to the power of 1. Okay, that is called 97.99 ohms. Like this, we will verify the Thevenin's equivalent resistance and different node voltages and currents. Okay, so this is about program to find the node voltages and the Thevenin's equivalent resistance and current by using PSPICE program for different values of that is called dependent sources. That is called voltage dependent current source, voltage dependent voltage source. Okay.